All right, so we're going to set up our camera, talk theory a little bit before we actually get to rendering anything. So what I've done is I've taken my camera, and what I want to do is set it up at a point of view that seems reasonable for where you would be standing when you play pinball. So something like that. And we're going to kind of adjust the position. And the idea is to project all of our textures from this point of view. And we need to do it in a way that also allows some flexibility so that as we adjust, either desktop or full screen or however in visual pinball, that it's not going to break all of our textures. This is okay, but I want a little bit more of an angle on this. So something more like this maybe, I think is good. Our focal length is like 50 millimeters. I actually want a little bit more of like a fisheye, because that will give us a little bit more perspective on all sides, as if we went in and looked at the game with a like really wide angle lens. So I'm just setting this up and bring the sensor in, so we're still looking at it with the 22 millimeter lens, and it's actually even yeah, anyway, you get the idea. So we're just going to take a look real quick, and that's pretty good. We're getting close. We want to make sure that our topmost elements, which are going to be like these plastics, are going to be visible, and we want to be able to render the lockdown bar from this point of view as well. So just a little bit of tweaking to go. And that's probably just right. And then we can take, what I'm trying to do is change the aspect ratio here to fill the screen like we want as absolute much as possible. Going to maximize the resolution we have. Let's do that, and then, whoops, dumb. Fixed, yeah, okay. Okay, so that's going to kind of maximize what we can see. And what I've done here is I've created 4 layers plus a bakery layer, so that we can choose which elements we render in which pass. Now all the other things are still going to affect shadows and everything like that unless we turn them off. But we need to do this in a specific order because of how depth bias works in visual pinball. It stacks layers and only gives transparency to the layers that have like a lower depth bias. So we're going to start right at playfield level. That's our layer 1. So let me just show you what I have selected for that. Okay, all of these elements are layer 1. And this is just telling me I need to move the camera down the tiniest bit yet, because it looks like the top of the cabinet's getting clipped. So, and what we have to do really is take a look and evaluate. Every game is different, and as elements get too close to each other and overlap, it breaks things visually, depending on where you are and what the game is. So let's just take a look and see if this works. So what we're going to do is we want to look at only these layer 1 things. So we're going to just solo those from the point of view of the camera. There. We can take a look and see what things are and are not working. Okay. We're avoiding these small places where things could overlap, so that's really good. Space there, that's really good. yeah, overall, I think we're in great shape here. And then just as an example, we could go and look at layer 2, and you'll be able to see which things are on layer 2. Forgive me, I should have done that differently. So here's a look at all the things that are on layer 2. And we don't see any major overlap except right here, which is fine because you don't see this metal in the game. You know, and we're talking like an extreme angle if you do, which, you know, that's your fault for using DirectX 9 games and expecting perfection. So, yeah, I think we're okay here. There's a post here that's going to be over this, and so that's not a problem. I just don't see any big issues. So that's layer 2. And I'll show you all of these so that I can do some of this really quickly later, and you'll know what's going on. I don't think I'll stop and review each of these. Okay, so here's layer 3, and here's where we have a couple of problems. You see our targets up here. There's the overhang of the plastics is in the way. So I'm going to move these to 2 and see if we can get away with it. Otherwise, it'll go to 4. And 4 is okay in this case, I think. So that's that. And then 4 is a lot of small stuff. Yeah. A lot of screws and speed nuts or whatever they're called. Some stuff for the apron. But that's all topmost stuff that needs transparency above the other elements. You know, I couldn't do this and just because it fits here, put a post or a rubber because of the way the depth bias works. You would see artifacts through it or not be able to see through it. Something would disappear behind it, at least at the edges of it, and would look screwy. So, you know, we have to be kind of meticulous about this. All right, anyway. So then what we do is we go through each of these layers, select everything, and we turn everything's ray visibility off to the camera. So 4 is off. Two is off. And really there's a faster way to do this. Just grab everything that you want to be on, like that. So everything in layer 1 is on. And we're going to inverse. That grabs everything else. And we're going to turn it off. And that's just by holding Alt. So now if we actually go to render view, you're going to see what the effect is. Our light works. We actually have shadow from the elements that are, you know, on the play field. But we don't actually see those elements. So they're still affecting our rendering. We're just not looking at them. And that's kind of the magic trick to get this to work, because you're getting a texture of all these things, but you're able to stack them and see around them and still get, you know, nice ray traced, pardon me, I'm tired, ray traced lighting. So, so now what we do, because our camera is set up where we want, we can render this, and then we'll talk about the next thing. So here's our first render, and I need to redo it for a couple of reasons, but I'll stop and point out why, just so that you know what kind of things I'm looking for here. So you can see right here, there's an overlap, and I don't want that overlap there, so this is going to have to move to a different layer. Fine, no problem. You know, some of this kind of overlap just doesn't matter, shouldn't bother anyone. The cool thing, and I'll just point this out quick, is that you can already see the benefits of some of those extra details. I mean, look at the way, like, that screw going through the post is visible. You know, those are like the details that you just don't get if you don't ray trace these things. So I think that's really, you know, that kind of stuff is really fun to look at and see. You can also see, though, the importance of having all your ducks in a row before you do your renders. I mean, look, even this, we're committed to yellow flippers. They show up right in the render. So so I'm gonna get rid of this. I forgot to turn on my outer wall, so we'll redo that. None of these actually need to be on. They're not helping anything. Those aren't visible, the ones beneath the inserts. So that'll speed up our render a little bit. And just a couple notes on render. I used 500 samples and then a compositing setup for denoising. Anything under, I don't know, I think anything under 500 I was losing too much detail. I wasn't real happy with it. Realistically, you could probably do 250 if you really needed things to speed up. I'm using my GPU. Sometimes I run into memory issues where things will really grind to a halt, and then I switch over to CPU, which is slower to render but doesn't run into the same memory problems. So something to think about. And the other thing I'm doing is I'm rendering at 4096 by 8192. And that's double the resolution I'm going to use in the game. And the denoiser works better at this resolution. You lose less detail. And downscaling, rendering and then downscaling tends to look better than just rendering at exactly the resolution you want. Same with photography. You shoot at the highest resolution and then scale down. And, a scaler that's not working in the moment tends to... Anyway, forget that. I'm not going to talk more about that. Anyway, so those are the things that I'm looking at that I kind of have to think through here, and then I'll render this again, and then we can talk about how to get it into Visual Pinball. Okay, so now we have a nice clean render of that first layer with the GI on. Great, so we save that. And then we're going to do the exact same render but with no GI. So we just turn that off for our render, and then we can reduce our sampling by half at least, because without all those lights, there's very little noise. So even 250 is overkill here. And here's our finished layer 1 texture with no GI. Can scale those by about half, and then bring them right into Visual Pinball.